Hi guys, in this video I'm going to go through quiz 1 on qualitative analysis or the QA. QA is in the salts chapter. Now, in order to do QA questions, you need to memorize the cation and the anion test first. This is the salts mind map and this is the cation test. Okay, so this chart and this table are basically the same. So as you can see, in order to test for the cation or the positive ion in a solution, you need to use either sodium hydroxide or aqueous ammonia. And besides a cation, you also need to memorize this table here, which is the anion test. There are 4 anions in our syllabus: the carbonate, the chloride, the nitrate, and the sulfate. So for example, how do you test for chloride ion? So you need to first add dilute nitric acid followed by silver nitrate. And bear in mind that the function of the nitric acid is to react with any carbonate ion that could be present, because the carbonate ion will also form white precipitate with silver nitrate. So in order to eliminate the possibility that carbonate ion could be present in the solution, you need to add the dilute nitric acid, because acid reacts with carbonate to form salt, water, and carbon dioxide. Now let's go back to the quiz. Okay, so this flowchart you have at the top the powdered metal. So of course powdered metal, I wouldn't know what is it. Okay, then it reacts with dilute sulfuric acid. So this is a metal acid reaction. Okay, metal plus acid. You should know that from the acid bases chapter. You should know that it forms salt and hydrogen gas. And true enough, this part is the hydrogen gas. Okay, apply a burning splint on the colorless gas S, and then a pop sound is heard. So this S is hydrogen gas. Okay, so which means that your T must be the salt, But what is the name of this salt, of this green solution? Now the color of the solution actually give you a very strong hint that green color, as you can tell from the cation chart, green color very likely Fe2 plus, it's present. Okay, and over here would tell you that add acidified aqueous barium nitrate. So acidified aqueous barium nitrate means you add nitric acid first, then followed by your barium nitrate. Yeah, so that is add acidified aqueous barium nitrate. It means add dilute nitric acid first and then followed by barium nitrate, and then you get a white precipitate. So again, from the anion test, you can tell that you should be able to know that what ion is present. Okay, so which is basically this part. Add dilute nitric acid, barium nitrate. So a white precipitate of barium sulfate is formed. So which means that sulfate is present. Okay, which means that sulfate is present, and the white precipitate is, and this white precipitate here is actually the barium sulfate. This one is barium sulfate, BaSO4. So which means that sulfate is present. Okay, so this green solution has sulfate, but sulfate is a negative ion. But how about the positive ion? The positive ion, this part will tell you, because add aqueous sodium hydroxide. Sodium hydroxide is a chemical used to test for cation, and then you get a green precipitate. So this part actually confirms that Fe2 plus is present, and this green precipitate would be iron 2 hydroxide. So if you add for all the cation test, right, the precipitate form must be something hydroxide. Because the cation test, you add sodium hydroxide or aqueous ammonia, and aqueous ammonia is the same as ammonium hydroxide. So if you get a precipitate after adding sodium hydroxide or aqueous ammonia, the precipitate must be something hydroxide. So in this case, green precipitate, it's confirmed that it is iron 2 hydroxide. So basically, all the unknowns have been made known already. So which is your green precipitate is iron 2 hydroxide. Your white precipitate here would be barium 2 sulfate. And then your T must be iron 2 sulfate. And then of course your S must be hydrogen gas. And then how about the metal R? Yeah, the metal R must be iron. This metal R must be iron. Okay. Now this metal R is not iron 2 plus. It is not iron 2 plus because iron 2 plus is not a metal. Iron 2 plus is an ion. Yeah. So for the metal, it must be iron, not iron 2 plus. Okay, write a chemical equation for one of the chemical reactions shown in figure 1.1. So there are many reactions here. First reaction, you can look at this one, okay, which is right here. So your T is iron 2 sulfate. So iron 2 sulfate plus your acidified aqueous barium nitrate. But in this case, you don't write the acid, you write the barium nitrate. So barium nitrate. Yeah, because the acidified is in case carbonate ion is present. So this one, then you get barium sulfate plus iron 2 nitrate. Okay, sorry, it's not very clear. So this is iron 2 sulfate plus reacts with barium nitrate, you get barium sulfate and iron 2 nitrate. How about the state symbol? So this one would be AQ because it's soluble. Barium 2 nitrate would be AQ as well. Barium sulfate is solid because it's insoluble, and iron 2 nitrate, it is AQ. Okay, this guy here, it's AQ. So this is one of the possible answers. Another possible answer would be this part. Yeah, again, green solution, iron 2 sulfate plus sodium hydroxide. Okay, and then you get a green precipitate. Remember, after you add sodium hydroxide or aqueous ammonia, if you get a precipitate, the precipitate must be something hydroxide. So in this case is iron 2 hydroxide plus sodium sulfate. Sodium sulfate is not NaSO4, it's Na2SO4. Na2SO4. Because sodium is Na plus, sulfate is SO4 2 minus. And then when you cross multiply, you get Na2SO4. So when you balance it, you need to put a 2 here. The state symbol, this is AQ. This is also AQ. This is solid, okay, because iron 2 hydroxide, it's a precipitate, and this is AQ. Okay, this is a second possible answer. Now the last possible answer is actually this part, the iron metal and the sulfuric acid. So iron Fe, okay, which is a solid, plus sulfuric acid H2SO4, which is an AQ. Okay, pardon me for my handwriting. And you get iron 2 sulfate, which is AQ, plus hydrogen gas, which is a gas. Okay, I think it's balanced. So this is the third possible answers. So there are actually three possible answers for writing the chemical equation. Oops, sorry. Okay, let's look at question number 2. Complete the table below for the missing reagents needed to test for each of the following anions in aqueous salt solutions. Yeah, so in order to test for sulfate ion, what are the chemicals or what are the reagents that need to be added? So let's refer to the mind map. Okay, sulfate ion. So what are the chemicals? So you can see these are the chemical. Dilute nitric acid, or just nitric acid, simply nitric acid will do it, and then add barium nitrate or barium chloride. Okay, so this one is your nitric acid, HNO3, or you can just spell out nitric acid and then barium nitrate. How about the nitrate ion? So nitrate ion you need. So if you go back to the same table, the anion table, you'll be able to find out that in order to test for nitrate ion, you need aqueous sodium hydroxide and aluminium foil, or just simply aluminium will do. That's for question number 2. Now let's look at the last question. Calcium oxide. Okay, calcium oxide. Add excess water, you get colorless solution. Then after that, bubble in carbon dioxide gas, you get a white precipitate. Yeah, so this part basically is how do you test for carbon dioxide. In order to test for carbon dioxide, you need to bubble the gas into the lime water, which is actually solution P. This is your lime water, and the chemical formula or the chemical name for lime water is calcium hydroxide. This part you need to remember. Calcium hydroxide is actually your lime water. Okay, so we already solved one. Colorless solution P is the lime water or calcium hydroxide. Bubble in carbon dioxide gas, you get white precipitate Q. So the white precipitate is the calcium carbonate. So for this reaction, right, the chemical equation is actually like this. Calcium hydroxide plus CO2, you get CaCO3, okay, which is the white precipitate plus water. So this chemical equation is shows the reaction that takes place when carbon dioxide is bubbled into lime water. So this is your white precipitate, this is your lime water. So this chemical equation you must remember. And one thing to take note is that whenever you have a metal oxide, you add water. Okay, this part, metal oxide, you add water, you get most of the time you get metal hydroxide, which in this case calcium oxide reacts with water. So it's the chemical equation is like this. Calcium oxide, you add water, you get calcium hydroxide. Okay, now let's look at the right hand side of the flowchart. Calcium oxide, add dilute acid. Yeah, this part. And then you get a colorless solution R. I don't know what is that. And then after that, this part will tell you colorless solution R, add acidified silver nitrate solution. So again, add acidified silver nitrate solution is the same as add dilute nitric acid followed by silver nitrate. So this is a test for chloride, and the white precipitate is the silver chloride. Okay, what am I talking about? I'm actually talking about this part. Yeah, so the white precipitate is the silver chloride. Okay, let's go back to the quiz question. So your S is a silver chloride. So which means that your colorless solution R must have chloride inside. This colorless solution R must have chloride inside. Where do you get the chloride? Because there is no chloride in calcium oxide, so the chloride must have come from the dilute acid. So what kind of acid? What acid has chloride? That's hydrochloric acid, HCl. Yeah, calcium oxide reacts with hydrochloric acid, so that's acid base. Calcium oxide is a base. Okay, acid base reaction, you get salt and water. So which means that your R is calcium chloride. Okay, your R is calcium chloride. Your white precipitate S is silver nitrate. A silver chloride. Your white precipitate Q is calcium carbonate, and the colorless solution P is calcium hydroxide. And of course, your T, dilute acid T, is hydrochloric acid. That's the end of the quiz, as well as this video. Thank you for watching. Bye bye.